Let's take a look at this problem. It says perform the indicated operation and reduce your answer to the lowest terms. Now this is adding and subtracting rational expressions. So let's refresh our memories on that. So adding, subtracting rational expressions. Step 1, figure out the LCD, least common denominator, and rewrite each fraction with that new denominator. Step 2, add or subtract the top parts and put into a single fraction. So we're going to add or subtract the numerators and put it into a single fraction. Step 3, factor the top, factor the numerator, factor the bottom, factor the denominator. And step 4, cancel if possible. So let's take a look at these applied to this problem. If I can. There it is. For my tablet. Okay, so we got 3x squared over x squared minus 4 plus 4 over x plus 2. Step 1, figure out the LCD and rewrite each fraction with any denominator. To figure out our least common denominator, or LCD, we first have to factor all our denominators. Now x plus 2 we can't do anything with, but x squared minus 4 is the difference of two squares. Two terms with a minus tree in it. Now, with difference two squares, we try to write it as something squared minus something else squared. And you ask yourself, what times itself gives you the x, and that would, or the x squared, and that'd be x. And then you ask yourself, what times itself gives you the 4, and that'd be 2. Now, this is just a formula. I'm going to label what's inside the first set of parentheses as f for first. I'll label what's inside the last set of parentheses as L for last. And our formula says f plus L times f minus L. So wherever we have an f in our formula, we'll plug in x, and everywhere we have an L in our formula, we'll plug in 2. So we got x plus 2 times x minus 2. Okay. So we're going to have x plus 2, x minus 2, and that's 3x squared, and this is 4 over x plus 2. Okay, let's figure out what our least common denominator is then. Now I'll start with the first factor. So I'll start with x plus 2. And I'm looking for the greatest number of x plus 2's in any single denominator. There's one here, there's one here. So the greatest number of x plus 2's in any single denominator is 1. I'm not counting how many there are. I'm looking for the greatest in any single denominator. Then I go to my next factor, the x minus 2. And I'm looking for the greatest number of x minus 2's in any single denominator. There's one here, there's none here. So the greatest number of x minus 2's in any single denominator is 1. So this would be our LCD. Okay. Now we want to rewrite our fractions with that new denominator. This one already had an x plus 2, x minus 2, so that hasn't changed. I'll leave it alone. My second fraction, though. It had an x plus 2. That x plus 2 is still there. The new item down below is the x minus 2. Well, whatever new item you have down here, you have to also put up on top. The mathematical principle behind that is whatever you multiply by the denominator, you have to multiply by the numerator. Which is going to give us 3x squared over x plus 2, x minus 2, plus 4 times x is 4x, 4 times negative 2 is negative 8 over our denominator. Now we never get rid of the parentheses down below because we're hoping they'll cancel at the end. Okay, step 2. Add or subtract top parts and put into a single fraction. Well, we've got a plus here, so we're just going to have 3x squared plus 4x minus 8 all over x plus 2, x minus 2. Step 3. Factor the top, factor the bottom. Well, if unless you got rid of the parentheses down below, you should never have to worry about the bottom part. Now our top part. If it'll factor, it'll be the key number. Reason why is we have x squared, x, no x, and there's a number in front of our x squared. Now with the key number, I'm going to do it over here on the side, or attempt it. With the key number, we're going to take the number at the beginning times the number at the end, ignoring signs. So we got 3 times 8. Now when I say a number at the beginning, I'm talking about the number before the x squared. I'm talking about the number at the end, I'm talking about the constant term, the 8. Now we're going to come up with our 3 columns, P, S, and D. Now P, we're going to write down all products give us 24. We got 1 times 24, 2 times 12, 3 times 8, 4 times 6. We're going to add those for the S column, S for sum. 1 plus 24 is 25, 2 plus 12 is 14, 3 plus 8 is 11, 10 plus 6 is 10. Okay, and difference column, we'll subtract them. Smaller from larger. 24 minus 1 is 23, 12 minus 2 is 10, 8 minus 3 is 5, 6 minus 4 is 2. Let's see, let me double check all these. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Add them, subtract them. Okay. The reason why I was double checking it, the number we're looking for is a number in a middle term, which is a 4, and I don't have a 4 anywhere in my S or D column. So if you don't have the number in your S or D column, that means it doesn't factor. And since this doesn't factor, then we can't cancel anything, so that would be our answer.